Welcome to online classes. I'm Shilpa. We are learning OOPS through C++ subject. In previous lecture, we discussed multipath inheritance. We came to know what is meant by multipath inheritance and what are the problems we faced when we implemented this multipath inheritance. That is ambiguity in multipath inheritance we have discussed, and also we discussed how we can avoid that ambiguity of the compiler at the time of executing our program using virtual base classes. And today's lecture we are going to discuss about virtual functions. So normally before going to virtual functions, first let us recap what is meant by polymorphism. What are the different types of polymorphisms? Polymorphism is the mechanism which will exhibit more than one form. That is here, for example, if you take a function, a name and its prototype in the program, the program may consist of a number of uh, functions with same names but with different parameters or signatures. So that is here having more than one form for the same name. It is called as polymorphism. We have discussed this polymorphism concept and also we executed some programs on function overloading. Poly means many, morphisms means forms. Having more than one form for the same function or same operator. Also we discussed about operator overloading. That is also one type of polymorphism. Normally the polymorphism can be divided into two types, that is compile time polymorphism and runtime polymorphism. Compile time polymorphism again can be divided into two types, that is function overloading and operator overloading. So in function overloading, we can say if the program consists of more than one function with same function name, then that is called as function overloading. And operator overloading is the one if we are providing another meaning for already existing operator, then that is called as operator overloading. So this is about different types of compile time polymorphism. Now another type of polymorphism is runtime polymorphism. That is here it will not check at the time of compilation, but it try to bind to the appropriate function definition at the time of running. That is, for example, if base class is having one function add with default arguments, and there is one derived class which is derived from this base class, and it is also having same function name add with default arguments. And if you observe the definitions of this add function in base and derived classes, the definition may be differ. But here the base and derived classes are using same function name with same prototype in both the classes. Then if we are trying to access the function add in main, normally in inheritance concept, when we implemented the programs, always we create an object for the derived class. Using the derived class object, we can able to access all the members of derived class as well as the base class. So here using by creating object for the derived class, I am trying to call the function add with default arguments. So at compile time, the compiler checks whether our program consisting one function with the name add and with default arguments. That's it. It will not check for further. It checks only the existence of the function which we are calling, and it will not bother about whether the function is having multiple copies in the program or not. At compile time, it will not bother about this. But when the program is executing, then it tries to invoke the function definition with exact match. That is, in our case, the function add is in both the classes, base and derived classes. So when we are trying to call the function add by creating object for the derived class, then normally here that is the function, sorry, object which is created for the derived class. So when we are using this object to call the members of the derived class, always it calls only the members of the derived class, not the members of the base class. Here and we are having add function in both the classes, base and derived classes. When we are calling add using this object, then always it calls only that add function of derived class, but never it calls the add function of base class, because here that object is created for the derived class. Okay, so that means we are unable to access the base class add function. So this is the main drawback of having same name with same prototype in both base and derived classes. Okay, so if that is the case, how we can overcome that particular problem or ambiguity, or how we can call both the functions based on our requirement. If we want to call the member function of, that is add function of the derived class, how we can call that only. If you want to call the add function of base class, then how it can be implemented. We will discuss now, and of course that can be possible using this virtual functions concept. So now let us start our actual lecture. So here we are going to discuss about virtual functions. This is also called as runtime polymorphism, and runtime polymorphism can be achieved using these virtual functions. And if you observe virtual base classes and virtual functions, there is a clear difference between virtual base class and virtual functions. Virtual base class is used to create only one copy of grandparent to that is to store a derived that is child class. Now to get only one copy of grandparent to child, we use virtual base class. Here these virtual functions are used to access the appropriate function definition if the function with same prototype exists in both the classes, base and derived classes. Okay, and here virtual functions, when we use the same function name in both the base and derived classes, the function in base class is declared as virtual using the keyword virtual preceding its declaration. So in order to avoid the type of problems, that is because always it calls only the member function of the derived class, not the member function of the base class. So in order to overcome that particular problem, we use virtual functions. So if how we can use these virtual functions in our program. So the virtual function in base, that is the function in base class, is declared as virtual using the keyword virtual. So if you want to make a particular function that is which may have same function name with arguments in its preceding classes, then we need to declare the base class function as virtual using the keyword virtual. When a function is made virtual, then this C++ determines which function to use at runtime based on the type of object pointed to by the base pointer. That is, here we create one base pointer, okay, and we assign the object of either base or derived class to this base pointer. So by observing the base pointer value, the compiler will decide whether it has to call the function of base class or the function of derived class. So here when a function is made virtual, then the C++ determines which function to use at runtime. That is, which function has to be invoked at runtime based on the type of object pointed to by the base pointer. So based on the object which is assigned to the base pointer variable, it decides, that is the compiler decides whether it has to call a function of either base or derived class. Thus, by making the base pointer to point to different objects, you can execute different versions of the virtual function. That is, here simply we assign different objects to this base pointer, so that what we do, we can execute different versions of the virtual function. That means here base class is having different definition from the uh, same function which is defined in the derived class. That means here, but we are using same function name with same prototype in both the classes. So using this type of functions, that is making the base class function as virtual, we can execute different versions of the virtual function. Okay, that is by assigning object to the base pointer. So first we will see an example program how these virtual functions can be used in our program. See, first there is one class, that is base, which is having two member functions simply. Void display, what it do, it's simply displaying display base, and one more member function, that is void show, and it simply displays show base. Display function which displays a single statement display base, and show function which displays show base. Okay, and here if you observe the code, here we are making this show function as virtual function. How we can say we are making this as virtual function? Because here we use the keyword virtual preceding the name of the function. Okay, so here we are making this show as virtual, and here we are deriving a class that is derived from the base class. Again, it is having two member functions, that is void display and void show, and display function is having only one display statement, that is display derived, and show is having one output statement, that is show derived. Okay, if you observe, the both base and derived classes are having two member functions with same names and same prototype, display and show, but we only made this show as virtual in base class, not the display. Okay, we are not making this display as virtual, we are making only the show function as virtual. Here display is not having any keyword virtual, only it is having, show is having virtual. Okay, and we are using same function names in even the derived classes. Okay, now in main, by creating that is we created two objects for both the classes, that is base and derived, base B and derived D, and also we created one base pointer, that is base star bptr, and here simply one output statement cout pointer points to base, so that here this base pointer is pointing to the base object. Okay, so that is base pointer ptr equals to address of base object, base class object, and after that using this ptr variable we are calling functions of, that is these two functions, that is display and show. Okay, and after that we are printing pointer now points to derive. So here this ptr equals to address of D. That means now this PTR is pointing to derived class. And using this PTR, we are calling display and show methods. Here also, by assigning base object to the base pointer, we are calling display and show. And even here, by assigning object of the derived class to base pointer, we call display and show methods. Now we will see what happens. That is, one thing we need to remember is here both base and derived classes are having two functions, that is display and show. Both are having the same prototype, display and show, but we made this show as virtual in base class. And of course all these four functions are having its own definitions. And in main, by creating object for the base pointer for the base class, and by assigning either base class object or derived class object to this PTR base class pointer variable, we are trying to call the display and show functions of particular class. Now let us execute this program and we will see what happens and why it is getting that is what we can learn by executing that. Hash include IOStream, hash include Conio. So we are having one class base, class base, and it is having only two member functions. So here we are concentrating on virtual functions. So we are not at all taking any data members, and we are not assigning and we are not performing any operations on that. Simply we want to know what is virtual functions. So that's why void display simply cout cout display base display base. Okay, and one function void show. Here for what we are doing, we want to use same member functions in both the classes, that is base and derived classes, and we want to examine or we want to observe what may be the output if we use both the that is the names of functions are same in both the classes, that is base and derived classes, and whether we can make then how we can rectify that problem. Okay, and that is that can be possible using these virtual functions, and we will use the keyword virtual at the time of declaring the function in base class. So first let me write only as normally, that is void display base, and here I am not making either of these two functions as virtual first initially, and let us execute this and we will observe what may be the uh, errors or what will be the output if we use like this same function names in both the classes, that is base and derived classes, what happens and how we can rectify that we will see in this particular program. So class derived from base, that is publicly public base, and public same functions I want to use in both the classes. Void display with the same signature, with the same prototype, but with different output statements. here this is display function of derived. So display derived, display derived, and also cout this is show of derived, show derived. Okay, this is only the definition of this derived class. And in main, into main, create object for both the classes base b derived b, and also create one pointer variable for base class base bptr base pointer bptr. Okay, and for our understanding purpose, one output statement bptr points to base, bptr points to base class, base class, and ptr bptr bptr equals to address of base object is b. Okay, now use this ptr to call the functions display and show bptr. So in order to call the member functions using pointer variable, we need to use arrow, bptr arrow, display, display, and bptr show. Okay, and now see out. Now bptr points to derived class. And now bptr equals to address of d, address of d, and using this d, that is bptr, call these functions display and show, display and bptr show, show, and then get ch and return 0, get ch return 0. Okay, now save the file. Virtual functions, function, virtual function, or just say function. Now compile the program. Base must be a previously defined class as struct, cannot convert base derived to base star, and declaration terminated incorrect. are getting some errors that base cannot be. Okay, first let me close this base here. Okay, and save the file. Again now compile the program. No errors. Run the program. See, if you observe the output, BPTR points to base class, and here as it is pointing to base class, so obviously in base class display function simply having one string to print on monitor, that is display base, and show is having one string show base to print on monitor. Okay, that's fine. And if you observe the second statement, that is now the BPTR points to derived class, not the base class. But here we are getting same output like previous one. That is, here we are getting two statements. That is, when you call this display, it is executing only the definition of base class display, because here we are getting display base and show base. Though here observe this output. First, BPTR points to base class. So we are getting display base and show base. And next, BPTR now points to derived class, but it is calling only the base class, display function and show function. It is not um, calling derived class here. Derived class displays display derived. Derived class show is show derived. And here we are saying D only, that is object of the derived class to base pointer only, but you are getting that is here when you are trying to call this display and show using this BPTR, though we assign the point object of the derived to base pointer, it is calling only the display and show of base classes, not the derived classes. It is calling only the display entities of base classes. That means here when this derived class is derived from base class, then all the members of this base class will copied into the derived class. So when we by creating this object for the derived class, if we call these member functions with same prototype in both the classes, then always it calls only the base class objects, not the derived class objects in this case. In order to avoid this type of problem, we are using virtual functions. So for that, what we need to do, only we need to write the keyword virtual preceding the function definition. Preceding the function definition. That is, here again you observe first experiment what we did, we are using same function names in both the classes, that is base and derived classes, and by creating object for both the classes base and derived, and by creating a pointer variable for the base, if you are trying to call display and show of show functions using this BPTR, though we assign either the object of base or derived, always this BPTR calls only the definitions or only the functions of base class. So in order to avoid that, that means here in order to provide accessibility to the function definitions which are defined in derived classes, we need to make uh, the functions virtual in base class. Okay, that is the solution for that. So first thing, without virtual, we executed and we observed the output. Now, though this is the second case, though here we are having two member functions, here I want to make only one function as virtual function. Okay, and let save the program and compile it and run the program and observe the output. So now BPTR points to base class, and here display base and show base. So as our expectation only, because the base pointer using this BPTR, if we call it calls only the display base and show base. And next BPTR points to derived class, and first statement is it is calling only display base. Okay, but show derived. But it is calling show derived. That is here, if you observe the last line, here it is printing show derived. Previously it is printing only show base, but now it is printing show derived. That means here it is able to access the appropriate function from the appropriate class based on the value which is assigned to the BPTR. If we use the keyword virtual at the time of declaring the functions in base class. Okay, so as here we you made this show as virtual. So when we are assigning the object of derived to base pointer and using this BPTR, if you call this show, then it calls only the show function of derived class, because this show is virtual in base class. That means here when this object is assigned to the base pointer, now the compiler checks at the time of calling a function. Okay, so here by using this, by assigning object of the base class to the base pointer, that is BPTR, and if we are trying to call display function using this BPTR, okay, first it checks, as this is the that is base class function, it calls these two. Okay, and after that we assign the object of derived class to BPTR, and here using this BPTR we are trying to call display. So first always it goes to the definition of the base class. So now the compiler will jumps to this particular member function definition, that is which is defined in base class. Okay, so as this is not virtual function, it simply executes its body or its definition. So that's why at this particular statement we got display base. Okay, and after getting that output, now the compiler executes this particular statement bptr show. So initially it jumps to show function of the base class only, show function of the base class only. But here when it is examining this show method of the base class, it is also observing the keyword virtual. Is also observing the keyword virtual at the time of declaring this show function. So now what it do, it now jumps to initialization of BPTR. Okay, and here we assign the object of derived class to this BPTR. So now instead of executing base class show function, it executes show function of derived class, because object of the derived is assigned to BPTR. Okay, always, that is when we are using this type of polymorphism, that is runtime polymorphism, always it first checks the definitions of base class. If it observes any function as virtual, then it checks which variable, that is the which object is assigned to this BPTR. So based on the initialization of this base pointer, based on the initialization of this base pointer, the function will be executed. If we made the function declarations of the that is member functions of base class as virtual. So here BPTR show, first initially it jumps to show of base class only, but at the time of declaration this show function is virtual. So now it based on the assignment of this BPTR, it jumps to the show function of derived class. So here we are getting the output as show derived. Okay. Now let me execute again by again modifying. This is the third case we are discussing. Even I want to make this display as virtual. First, we didn't make any function as virtual. Okay, any function as virtual, and we observe the output, and we discussed about that. And after that, we make only one function of the base class as virtual, and we observe the output, and we discussed about that. Now, third case is I am making both the functions as virtual functions, and save the file and compile it and run the program. See, BPTR points to base class and display base show base. Okay. Now BPTR points to derived class and display derived show derived. Previously we got display base because at that time we were not made that display of base as virtual. That's why we got that base class display function was executed. But here we made both the classes of base class as virtual. That's why when the compiler encountered or tried to execute this particular statement, first it jumps to the definition of base class. Okay, it found the declaration of display in base class. Okay, as that display is virtual function, then it observes which object is assigned to this BPTR. Derived class object was assigned to BPTR, so it calls only derived class display function. Likewise, here also when it is calling this show function, it observes the show declaration of base class. Again here also that is virtual function. So again it observes which value is assigned to this base pointer. Again the object of derived class is assigned to this BPTR. That's why here it calls only derived class show function. That's why we got show derived. Okay. This is the use of virtual functions. Totally here we observe three cases. First, without making any of functions as virtual, and we observe the output. Always it prints only the definitions of functions of base class. And after that we made second case is we made only one function out of these two functions as virtual. So at that time only that function, that is when we calling the derived class function, if that is a virtual function, that the derived class definition will be executed, otherwise it prints or it executes only the base class definition. And third case we made all the functions, that is in this case two functions as virtual functions, and if we execute then appropriately, that is based on the value the object assigned to this BPTR, it calls the only that class member functions, only that particular class is member function. So this is all about virtual functions with an example. Okay, so now we must access virtual functions through the use of a pointer declared as a pointer to the base class. Always we can access these virtual functions based on the pointer declared as a pointer to the base class, because always here when we are calling display and base, in both the cases, that is when the pointer is assigned with the base class object or pointer is assigned with the base class object, we use only base class pointer BPTR. So in order to access the virtual functions, always we need to use only the base class pointer variable. And we use the object name the same way as any other member function to call the virtual functions. Okay, we use only the object names in order to call the functions, that is member functions. Repeat here as that is the pointer variable arrow function name. Okay, so BPTR show we call or we used in our program previously. And we can achieve runtime polymorphism only when a virtual function is accessed through a pointer to the base class. Always this runtime polymorphism can be achieved. Okay, only when a virtual function is accessed through a pointer to the base class. That is here, in order to achieve this runtime polymorphism, always we need to create a pointer variable for the base class by assigning the object of a particular class to this base class pointer. You can call the virtual function definitions. Okay, and what may be the applications of virtual functions? That is here we are going to discuss about one more program. Okay, uh, as a application of this virtual function. So here, assume there is a bookshop which sells both books and videotapes. So there is one bookshop and it sells both books and videotapes. And obviously these books and tapes are having title and price commonly. Okay, title of the book, title of the videotape, and price of the book and price of the videotape. And we can create a class known as media, and here this is the name of the class media that stores the title and price of a publication. So what this media class do? It simply stores the title and price of a publication. And we can create two derived classes. Okay, one for storing the number of pages in a book along with title and price. This book may consist of number of pages. So we are deriving a class book from this media class, and it is having only one member, that is number of pages, and another for storing the playing time of a tape. And here we are deriving another class, that is tape, which is having one data member, that is time, playing time of a particular video tape. Okay, there is one class media which is having price and title and price, and one class that is book derived from this media, and it is having one data member, that is number of pages. And we derived one more class from this media, that is tape, and here the tape consists of one variable, that is playing time. Okay, now so like that we are going to implement a program using these virtual functions. So this is class hierarchy: media, book, and tape. See, this is the base class media. It is having two data members, title and price, and one constructor, that is media, which invokes at the time of creating an object for this class, and which assigns the values for title and price, and one function, that is in this case especially this is a virtual function, and this is empty virtual function. That is in base class it is not having any definition. Okay, but we are going to implement this virtual function in its derived classes. In base class it is not having any definition. Okay, empty virtual function. But in derived classes we are going to derive uh, for this display. Okay, so here class book, that is this is the derived class from the media, and book is having number of pages, so int pages, and one constructor, that is book, which is going to assign values for that is the name of the book and price of the book. Actually they are declared in media using the constructor, and one argument, that is p, which is assigned to this number of pages. So here, in order to make use of the constructor of the base class and derived class, or in order to assign the values of derived class variables to the base class variables, here this can be used. Okay, that means here what it do, it assigns this string to the variable s, and this value a, float a, to a variable, that is internally it is calling the constructor of its parent or its base class. Okay, and third object, it is not having any third object in this case, that is media class. So this is assigned to pages, and it is having its own member function, that is void display. Likewise, here tape, which is derived from media again, and it is having one variable, that is float time, and again it is having one constructor which accepts three variables, and first two variables are assigned to the constructor of the base class, passed to the constructor of the base class, and third variable is assigned to its own data member, that is time, and it is having its own display. And here this is the display of book, simply it displays all the variables, that is title, price, these two are the variables of base class, and pages, this is the variable of its own class, that is book class. Okay, and likewise here we are writing the definition for display of tape. Again here also it is printing title and price of the tape and along with later. Okay, and in main, first creating or declaring these variables title, price, time. Okay, and we are reading values into these variables title, price, and pages, and we are passing them to constructor of the class book. Okay, and after that enter values for the tape. Again you need to enter title, price, and time, and we are passing them to constructor of the tape class. And after that we are creating two pointer variables for the base class, that is media, and using these pointer variables and by assigning the address of an object, either the object of book or object of the tape, we are going to access display functions. Okay, so list of 0, this is first pointer variable, and we are assigning the object of book, and using that pointer variable, that is list of 0, if you call display, then it displays book details, that is displays book details. And after that for the second pointer variable of the base class, we assign the object of the tape class. So when we call display using this pointer variable of the base class, then it simply display tape details. Okay, so in this lecture we discussed about virtual function, that is runtime polymorphism, how this runtime polymorphism can be achieved, that is using virtual functions, that runtime polymorphism can be achieved, and we have seen how this virtual function can be used in our program. In that is in the next class we will execute this and the program, that is creating a array of pointer variables for the base class in virtual function.